July 30th, 2025, 11:24 a.m. Kamchatka time. The Pacific Plate tears itself apart. Magnitude 8.8, the sixth largest earthquake ever recorded by modern instruments. A 390-kilometer rupture zone. Seafloor lurches upward by over 10 meters in seconds, displacing billions of tons of water. Within minutes, a 15-foot wall of churning ocean is racing toward the United States coastline at jetliner speed. But here's what they're not telling you. This wasn't just an earthquake. This was the Earth correcting a 73-year imbalance. And the correction isn't over. Scientists at the University of Tsukuba just published findings that should terrify anyone living on the Pacific coast. The 2025 Kamchatka quake released more energy than had accumulated since 1952. 9 to 12 meters of fault slip across an area half the size of England. The accumulated strain from 73 years was supposed to be 6 meters. The fault overshot by double. What does that mean? The stress didn't dissipate. It reversed. Low-angle aftershocks in the opposite direction of plate convergence. The fault is rebounding. Violently. February 2026, 6 months after the main shock. Kamchatka is still shaking. Magnitude 6.2 on January 22nd. Magnitude 4.6 on February 6th. Another 4.6 on February 7th. Magnitude 4.7 on February 11th. Over 3,493 aftershocks cataloged, 25 of them exceeding magnitude 6.0. Including a magnitude 7.8 event in September that scientists are calling an intense aftershock caused by shallow reverse faulting. The USGS aftershock forecast calculated a 24% chance of additional magnitude 7 or larger events. A 2% chance of another magnitude 8. Greater than 99% certainty of continued magnitude 5 and above activity. Those percentages haven't changed. The clock is still running. Here's the mechanism they discovered using potency-density tensor inversion. The rupture didn't just slip once. It accelerated twice within the large slip zone. 2 distinct pulses of energy release across the same fault segment. That's abnormal. That's a fault system under extreme, unresolved stress. And then there is the satellite data. NASA's SWOT satellite captured something no one had ever seen before. The July tsunami was not a clean wave moving across open ocean. It was chaos. A surprisingly intricate pattern of waves spreading, interacting, scattering across the Pacific basin. Not the stable, predictable wavefront that forecast models assumed. The tsunami was more complex, more scattered, more dangerous than scientists expected. SWOT recorded wave heights exceeding 1.5 feet in the darkest red zones, 70 minutes after the quake struck. But here's the critical detail. Those measurements were taken in open ocean. When tsunami waves hit shallow coastal water, they build. They amplify. A 1.5-foot wave at sea became 3 to 4 meters along Kamchatka's eastern coast. Up to 13 feet in the Kuril Islands. And in one narrow river valley near Vesnik Bay, the run-up height reached 109 feet. 33.1 meters of vertical water. Taller than a 10-story building. The wave traveled 5,000 miles to Hawaii in under 8 hours. Honolulu recorded 1.7 meters. Sirens wailed across Waikiki. The California coast saw waves slightly over 1 meter. Piers closed from San Francisco to Los Angeles. In Japan, 900,000 people across 133 municipalities were ordered to evacuate. Sendai Airport runways shut down. JR East, JR Central, JR Hokkaido. Rail services suspended. 1 indirect fatality. 21 injuries during tsunami-related evacuations in Japan. But let's talk about what didn't happen. The 1952 Kamchatka earthquake, magnitude 9.0, same fault zone, 45 kilometers southeast of the 2025 epicenter. That event generated waves over 15 meters high. Several thousand people died. The city of Severodvinsk was obliterated. 2025 was magnitude 8.8, nearly identical location. Shallow depth of 21 kilometers. Perfect tsunami setup. But the waves were weaker. Why? Because the fault slip pattern was different. The rupture didn't extend as far into the shallow trench. Less vertical seafloor displacement means smaller tsunami amplitude. This time, scientists are calling it a 73-year earthquake cycle. The 1952 event left residual, unresolved strain. That strain combined with 73 years of new accumulation from the Pacific Plate grinding northwest at 79 to 83 millimeters per year. 3 inches annually. Over 7 decades, that's 20 feet of convergence locked beneath Kamchatka. The 2025 quake was supposed to release that. Instead, it overshot. Dynamic overshoot, stress reversal. The fault moved too far. Now it's correcting, again. A paper published just days before the July earthquake warned of ring-shaped seismicity structures beneath southern Kamchatka. Earthquake epicenters distributed in elliptical rings at multiple depths. Existing studies show that large earthquakes usually occur 10 to 15 years after a sudden high rate of seismicity around these structures. In Kamchatka, that spike occurred in 2016. The paper predicted a large earthquake between 2026 and 2031. Magnitude 8.4 to 8.8. The July 2025 quake hit at the early end of that window, which raises the question, was July 2025 the predicted event, or was it the precursor? The foreshock sequence is disturbing. Magnitude 7.4 on July 20th, 9 days before the main shock, preceded by a magnitude 6.7 event just 1 hour earlier. 50 earthquakes of magnitude 5.0 or larger in a 10-day span leading up to the 8.8. 3 magnitude 6.6 quakes. That's not normal background seismicity. That's a fault system reaching critical failure. And the aftershocks continue to cluster. Magnitude 6.9 just 49 minutes after the main shock. Magnitude 6.8 on August 3rd. Magnitude 7.4 on September 13th. Magnitude 7.8 on September 18th. All within the same stress field. California felt it too. January 2026, Coachella Valley. Magnitude 4.9 north of Indio on January 19th. Magnitude 4.2 on January 21st. Flurries of tremors near Joshua Tree National Park. Different fault, different plate boundary, but the Pacific Rim is interconnected. Stress transfers. One major rupture can load adjacent fault segments thousands of miles away. The Kuril-Kamchatka subduction zone extends 2,100 kilometers from Hokkaido, Japan, along the Kuril Islands and the Pacific coast of Kamchatka. Since 1900, this arc has produced 133 large earthquakes, magnitude 7 or higher. 12 great earthquakes, magnitude 8 or higher. The 1963 magnitude 8.5 quake off Europe Island generated Pacific-wide tsunami waves with run-up heights of 4 to 5 meters. The 1923 magnitude 8.4 Kamchatka earthquake created an 8-meter trans-oceanic tsunami. This is a fault system that doesn't sleep. This is a subduction zone where the Pacific Plate dives beneath the Okhotsk microplate at 650 kilometers depth. Continuous subduction since the Cretaceous period. Over 100 million years of uninterrupted collision. The Ring of Fire. 40,000 kilometers encircling the Pacific Ocean. 75% of the world's volcanoes. 90% of its largest earthquakes. A planetary-scale fault network where stress accumulates silently, invisibly for decades, then releases catastrophically. Tsunami warnings were issued to 15 countries: Russia, Japan, Philippines, Indonesia, New Zealand, North and South America. Chile remembered the 2010 quake that devastated Concepcion. Alaska recorded seismic waves. Canada recorded seismic waves. Iceland's sensors detected aftershock ripples across tectonic plates. NASA's Guardian system, equipped with AI just 1 day before the earthquake, tracked the tsunami using GPS satellite orbit perturbations. The uplifted column of water pushed the mass of air above it, sending low-frequency sound waves and gravity waves into the ionosphere. Measurable distortions in satellite navigation signals. Real-time tsunami tracking from space. NOAA's Center for Tsunami Research tested their forecast model against SWAT's satellite data. The satellite observations allowed researchers to reverse engineer the cause of the tsunami, and the forecast was accurate, this time. But the satellite revealed something the models missed. Tsunami waves don't travel as single, stable fronts. They scatter, they interact with seafloor topography. They amplify unpredictably when local bathymetry focuses the energy. A 1-meter wave offshore becomes a 33-meter monster in a steep river valley. That's a 108-foot amplification factor. Coastal shape matters. Seafloor morphology matters. And we don't have high-resolution maps of every coastline. The Pacific Tsunami Warning Center issued alerts within 10 minutes of detection. But 10 minutes is not enough for near-field populations. Kamchatka residents had no time. The first waves hit 40 minutes after the quake. If you're on the coast, 40 minutes is the difference between life and death. And that assumes you feel the shaking, recognize it as a tsunami threat, and evacuate immediately to high ground. Most people don't. February 2026. The aftershock sequence continues. The 2025 rupture didn't fully resolve the accumulated strain. Segments of the subduction zone that didn't slip in July are now under increased stress. The aftershock zones of great historic earthquakes typically abut one another along the arc, but don't overlap. Sections rupture at fairly regular intervals, but the recurrence times are longer than the length of seismicity catalogs. We don't have enough data. We're flying blind through geologic time. The 1952 earthquake ruptured a 700-kilometer by 150 to 200-kilometer section. The 2025 event ruptured 390 kilometers by 140 kilometers. Those rupture zones overlap but don't align perfectly, which means there are unruptured segments. Seismic gaps, zones that haven't released energy for over a century, and seismic gaps eventually fill. Geophysicists are now re-evaluating the entire Pacific Rim. If Kamchatka can produce a magnitude 8.8 with a 73-year recurrence interval, what does that mean for Cascadia? For the Aleutians? For Japan? For Chile? The Cascadia subduction zone off the Pacific Northwest hasn't ruptured since 1700. 326 years of locked strain. The Juan de Fuca plate is diving beneath North America at 4 centimeters per year. That's 13 meters of accumulated slip deficit. Enough for a magnitude 9.0 event. Enough to send a tsunami towards Seattle, Portland, Vancouver. Enough to obliterate coastal infrastructure across Oregon, Washington, British Columbia. The 2011 Tohoku earthquake in Japan was magnitude 9.0. 15,899 confirmed deaths. Fukushima Daiichi nuclear disaster. The 2004 Indian Ocean earthquake and tsunami killed over 227,000 people across 14 countries. The largest earthquake ever recorded, the 1960 Valdivia earthquake in Chile, measured magnitude 9.5. Magnitude 8.8 is not the upper limit. It's the lower end of megathrust potential. And Kamchatka just demonstrated that these events can recur within a human lifespan. Millions were alerted within minutes. Evacuations proceeded, but 1 person died, 21 were injured. Infrastructure damage was moderate, not catastrophic. The tsunami waves were weaker than 1952. This time, we got lucky. Luck is not a strategy. The satellite data is being integrated into new forecast models. SWAT's high-resolution altimetry is unlocking new physics. Scientists are updating seismic cycle models to account for dynamic overshoot and stress reversal. Governments are reviewing early warning systems. Communities are rethinking coastal safety strategies. But the Earth doesn't wait for updates. February 11, 2026. Magnitude 4.7 near Ozernovsky, Russia. Another aftershock. Another release of residual strain. The fault is still moving, and no one knows when it will move again or how much.